Welcome! Today we'll solve a problem involving successive differentiation of a composite trigonometric and logarithmic function. Let's start with our given function, y equals cosine of the natural logarithm of 1 plus x. We need to show that this function satisfies a certain differential equation through successive differentiation. Let's find the first derivative. We'll use the chain rule since we have a composite function. The derivative of cosine is negative sine, and we multiply this by the derivative of the inner function, which is 1 over 1 plus x. To simplify our work, let's multiply both sides by 1 plus x to clear the fraction. This gives us 1 plus x times y1 equals negative sine of natural log of 1 plus x. Now, for the second derivative, we'll need to use the product rule on the left side and the chain rule on the right side. After differentiating, we get y1 plus 1 plus x times y2 equals negative cosine of natural log of 1 plus x times 1 over 1 plus x. Now, notice that the right side contains our original function y divided by 1 plus x. Let's substitute negative y over 1 plus x for this term. Multiply all terms by 1 plus x squared to clear the fraction. After rearranging, we get our target equation, 1 plus x squared times y2 plus 1 plus x times y1 plus y equals 0. And there we have it. Through successive differentiation and strategic algebraic manipulation, we've proven that our original function satisfies this differential equation.